start the recording. Okay, this competition is organized by the ISEKI-Food Association, or IFA. You see our logo on the right side of the slide. We are an independent European nonprofit organization, and our aim is to bring education, research, and industry together in the food chain. We participate in several European projects, and one of these is Next Food. And you see the project logo for Next Food also on your right. The Next Food project is conducting action learning and action research in 12 locations around Europe, Africa, the Americas, and Asia. And our Food Factory for Us competition is one of these research cases. And you can see in the next slide some of the story of Food Factory for Us. What exactly is Food Factory for Us? Well, it is a completely voluntary student competition, and it has been running since 2017. Every edition of the competition is on a different topic that's specific to food production. And teams of master's students self-organize into 3 to 5 groups of 3 to 5, and they identify a problem or a challenge that's related to the topic of the competition. And then they design a specific solution to that challenge that is relevant to the food industry. The team projects are evaluated by an advisory board, and this board is made up of academic, nonprofit, and industry representatives. And that means that the project evaluation is not like school. It is, in fact, a real evaluation. You see in the next slide that the structure of this competition is quite unique. The competition is completely online, and yet we foster a participatory, a learner-centric, and an action-oriented experience. This is not so easy to do online. The students participate in 6 online trainings, and these trainings are focused on the 6 core competences that you see on the left of the slide. These competences, we believe, are essential for students to learn to be change makers and to push the green shift in the agricultural world. For the last 4.5 months, the student teams have been working on their projects, and we'll hear about these from the teams in just a few minutes. And at the same time, they've been participating in the online trainings listed here. I won't tell you about all of these trainings, but I do want to mention 2 of my favorites. At the student presentation training early in the competition, at least one student from each team shares a practical experience that they've had, maybe an internship or a visit to a farm or a company. And the remaining students learn to observe the presentation very carefully so that they can make comments on what they find most interesting and why. In another of my favorite online trainings, the student suggestion training, the students tell us what they'd like to learn more about, and they tell us an interesting paper or presentation on this topic. Then we, the organizers, reach out and contact the authors of the presentation. And this competition, we were lucky enough to have the 2 authors come to our training and tell the students about their research paper. Then the students participate in a student-led reflection. Can we mute? Yeah, thanks. The students participate in a reflection in their own group, and they come up with some questions and comments for the invited speakers. So overall, we practiced these 6 core competences in the 6 online trainings, and we used many different methodologies and tools, ranging from observation to visioning your future success. Really exciting. And in the next slide, you see how the students are assessed. The student teams have been working on their projects since the competition began, and they submitted a project report and a series of presentation slides. And this report and the slides are assessed by the advisory board. They also assess the overall concept of the project. The advisory board does by reading the report and looking at the slides. And the final assessment happens during the conference today. The student teams will be assessed on their presentation skills, on the content of their presentations, and on their answers to questions. So please, don't be shy. And we have time at the end of each student presentation, 2 or 3 minutes, for questions from the audience. And in the next slide, you see why these teams really want to win. We have some fabulous awards for winning teams. The ISEKI-Food Association sponsors an award of 300 euros in cash to the winning team. We also will invite the winning team to the next food final project meeting, which is scheduled to be in Bari, Italy. And finally, the winning team gets a certificate justifying, acknowledging their participation and the fact that they are the winners. And now, finally, the next slide tells us about the topic of this competition, supporting and developing short food supply chains. This topic was decided together by the advisory board, and it was decided as a way to promote short food supply chains throughout the world by having students identify existing short food supply chains, work with an industry mentor, and propose a solution to improve the existing supply chain. So I think we're ready to meet the teams, and I'll introduce now my colleague and friend, Line Lindner, and Line will take over and introduce you to the 3 teams competing today. Line.
Thanks, Catherine. Yes, so now we're ready to listen to the interesting projects of our 3 teams. They actually represent 3 continents. We have Team Volatile from Mumbai in India. Then we have AG Economists for Local Food Access from Kentucky University in the United States. And finally, Audencia AgroChain from France, from the Audencia Business School. And before we start, let me just quickly summarize the rules, as we call them. Each team has 10 minutes to give their presentation. And then each team has 2 to 3 minutes where they can answer questions from you, from the audience. So we really kindly ask you to listen carefully and just ask your questions. It can be any questions. I can promise you the presentations are really interesting. And you can post your questions just by writing in the chat during the presentation or in these 2 to 3 minutes, or you can also raise your hand and we will open your microphone. And otherwise, please keep your microphones muted now when people are speaking. So we start now with the first team. That's our French team, Audencia AgroChain. They give their presentation called AgroChain App Digital Platform. And I will stop sharing, and then I kindly invite the team to share your presentation. Hello? It's a little bit echoey, and now it's better.
Mute your mic. The mic is muted. Okay, then it's okay.
I can unmute now for my.
Yeah, unmute that.
Can you put your presentation in presentation mode, please?
Can you hear us?
Yes.
Okay,
well.
great.
Maybe there's a little bit echo. Do you have 2 microphones on?
Hello, are we good?
Yes, it's good. Just put your presentation on presentation mode, then we're fine.
We are in presentation mode. Yeah, I think it is good.
Yeah.
I see your PowerPoint slides also on the left.
Not share the screen because it's not moving. This is the same program we had last week.
No?
No.
There's no way to share it.
Can we do something else? No.
Maybe upload it.
Yeah, upload the PowerPoint.
Little button, you know, on the right-hand side.
But are you sharing a screen? Maybe if you share a screen.
She's sharing the screen, that's why it's not working.
Are you sharing a screen?
What do we need to do?
Put in presentation mode.
Yeah.
No, but if and now it's working? Yeah.
I think you should unshare it and then keep in presentation mode and then share it.
Yeah, yeah, and close
Close,
what you
close
did.
it.
What you
Yeah,
did.
maybe
you
stop
put
sharing.
the
That's
stream.
true. Stop sharing.
Yeah.
Stop it. Yeah, stop sharing.
And then in PowerPoint, you put it in presentation mode and then you share only PowerPoint.
No, but where it says share screen? This one? No, but share screen, not PowerPoint screen. Is this one? Okay.
Okay, so now on the bottom of your screen on the right side, yeah, there you go.
Okay, now?
Yes.
There. Yeah, it's still not.
Yes?
right.
No, yes?
No,
Okay.
no, it's no good. We're gonna let it go like this then? Yeah, okay.
I think so.
Are you ready?
Yes.
Yes, please go ahead.
Hi, my name is Henry, representing the Audentia team. I'm here to present AgroChain Digital Platform. You may be wondering at this moment what this is about. Let me start by taking you back to our initial warm conversation with Robert, Audentia alumni and co-founder of Java Fresh, exporters of exotic fruits from Indonesia to other parts of Asia, North America, and Europe. The company's challenges with increased transportation and logistics costs have been worsened by the uncertainty of the COVID-19 pandemic. Addressing transportation and logistics issues have never been more important as we see in this pandemic. By bringing together different players, farmers and buyers, including Java Fresh, onto a digital platform, we can optimize the link between them via a truck pooling service by combining goods transportation of different buyers located in the urban areas from the farmers in the rural areas. In doing so, we will cut down carbon emissions and the consequent greenhouse effect by reducing individual transportation, enhance collaboration among different stakeholders, and increase their bottom line by reducing transportation and logistics costs. Thank you.
Hello, everybody. So, as you know, we are students from Audentia in France, Nantes. We are all students in food and agribusiness management master. And
We don't hear you now. You're muted.
Asia and Middle East. It was founded in 2014 and it collaborates directly with small farmers located in Java, Sumatra, and Bali. It supplies fresh 100% Indonesia fruits, and it was the first company to supply exotic fruits from Indonesia to the market in France.
Java Fresh problems include tracking and freight, including the cold chain. Sometimes in the year, when the market price is low, the enterprise would rather do not sell. Neither the farmers want to sell because the tracking cost per unit is more expensive than the market price, so they would be losing money. The plantations of the farmers are very far from the city. The freight carrier is why when prices go down, they do not sell internationally. It's not even imaginable to sell locally since they were losing more money. So what happens with farmers' products during this season? All goes to waste and they do not make any revenue. And this is the collateral damage for farmers.
So we have had a closer look at our company's, at our mentors company's cooling chain, and we have found that a particular bottleneck is around the airport cooling facilities. And he has told us that it is particularly difficult to manage properly timing of those cooling facilities, particularly when flights are cancelled. And so it would be very helpful to have a tool at hand that could manage and show the availability of different facilities and also trucks, of course. And so we came up with a project that actually has several steps. So of course, the first stage is to develop an app that helps managing and overviewing of those cooling facilities. But as we have learned in the ISEKI sessions, it is also very important to think of it in a bigger picture. And so we thought that out of the apps, we could also develop a digital platform that brings together all the different stakeholders so that we can create more sustainable cooling chains. And also because of that platform being an informational platform, we could help to transfer knowledge, and thus potentially intermediaries can be skipped, and so we can create shorter supply chains. How do we plan to develop it? It seems a little bit ambitious, a whole digital platform, but we plan it as a bottom-up effort so that each app shall be developed depending on the needs that are actually there. For instance, here we have sketched an overview of how a display could look like for a truck hauling service. And so this is something that could be readily realized.
Hello, so I'll be taking you through our intended application. And as you can see, as Lydia stated, we intend to include all stakeholders, and the major key stakeholders are the farmers. And one may ask, how will the farmers have access to mobile phones? Perhaps mobile phones are expensive, but we also intend to link them with either mobile service providers or mobile selling companies. So this is what some of the services our company will provide. For instance, insurance for farmers, marketing, tracking of value chains, consulting and education that might teach them about post-harvest loss, and of course, increase money and prevent losses for them. But most importantly, as you can see, truck hauling service that is intended to reduce cost, for Java Fresh and our partner is also included in this application.
About the business perspective, we would have to split the project into two stages. In the first stage, the major objective will be to build a free knowledge and information network. This is very important as we need to familiarize the platform to the different users. In the second stage, we will add a sort of service marketplace. Some revenue can be expected from advertisement and commissions. At this stage, we need to be honest and say something that it's not a new. Looking back to other online services platforms were not profitable for the first few years. Thus, also sponsorship is important. And another important drawback of an online platform is moreover the consultancy tip getting information online, but bypassing the platforms for deal making.
So, social responsibility is at the core of our idea, and it's important, and that is why we have input the 3 Ps in our business idea. And the first part of this is to look at the people involved in this process. The AgroChain platform connects actors along the value chain, improving welfare and knowledge. We also look at the planet in creating short and sustainable fresh fruit supply chains and reducing carbon emissions. Last but not least, we look at improving profits. How do we do this? By reducing transportation and logistics costs associated for the transportation of goods. Thank you.
Thank you very much, Team Audencia. Thank you very much for this really interesting presentation, and listening to all of you was really great. Do we have any questions in the chat, or is there anyone who wants to ask a question? You can also just open your microphone and then ask your question.
May I ask a question?
Yeah, Gerhard, go ahead.
Thank you very much for this interesting presentation. It looks very nice project, but I think this would also be a challenging project. I guess you are coming from a kind of business school, is that right?
Yes, this is right.
Yeah. So I'm wondering if, because to make a success story of this idea, I think it's important also to have a closer look to the economics, to the business. Did you start making a kind of business plan or something? What kind of competitors you have? What clients? What is the market? We cannot hear you. You are muted.
Yes, is it better now?
Yeah.
So there's a major player involved. We worked with a company in Indonesia, and we know there's a major player involved there currently, but their system doesn't handle exactly what we just proposed. What do they handle?
The name what?
So yes, Tiny App. So they did not deal exactly. They did not concentrate on the different players or the different players in the food supply chain. They did not concentrate directly on the buyers or the distributors. So we aim to differentiate ourselves by Uberizing truck services so that we can optimize transportation. What do they actually do? The honey. The honey. What do they do? The honey people. Continue. So, in essence, we are differentiating. We differentiate ourselves. They did not cover this side of the market, and so we are targeting providing a platform that can bring together different buyers.
And to add on what Henry just said, other than looking at a company that is also doing the same services like we want to put, we also looked at several supply chain applications, and we mostly observed they only focused on one services. So to add values, we asked ourselves, what will be good for application? And hence, if you've seen on the slide we showed, there were several services other than just truck hauling that will be very valuable to all the stakeholders that will utilize AgroChain application. Thank you.
I think it would be a very valuable tool, but how do you how do you want to finance this, the development of this tool?
Yeah, the financing is indeed a little bit tricky. So, because this is some sort of service platform similar to Fiverr, so it's tricky because we have to be honest that, for instance, this highly successful platform did not get profitable in the first decade or so, but the digitalization of several sectors has gained a lot of tractions from different investors. And also highlighting that this is a very responsible project, not just for making profit, but also for transferring knowledge and skills. So therefore, I think it might be interesting for maybe governmental help. And as far as monetarization is concerned, we could have ads. We could also ask for small commissions on the deals that might be accomplished on that platform. But indeed, that is a very tricky subject, the financing.
But
okay. Yep.
Also, in addition to that, participating in programs or competitions like this is to enable us to get the view and also expose us so that we can get financing. We discussed this with our mentor who has this problem, and he knows the terrain very well. And our aim with competing in this project is to help us get the exposure and also try and raise funds with investors. So this is how we look at we are looking to finance this project.
Okay, I understand. Thank you very much.
Great. Thanks very much, Gerhard, for your question and for your answers also. I think we have to move on with the next team. So if you can please stop sharing your screen, Team Audencia. Now it's time for our team Volatile from India. I hope you're here. You can share your screen. I saw there was a question.
Hi.
Yeah?
Yes, we are here. So from Team Volatile, Maruti would be presenting these
Yeah,
slides.
can you please stop sharing the previous slide?
Yes, Team Audencia, you have to stop sharing. Yes.
Yeah, thank you.
Yes, we see your screen.
I hope my
Yes.
slides are visible and they are in,
Yes.
slideshow mode as
Yeah.
well.
Yeah,
They are
that's
perfect.
great.
You can go ahead. Thank you.
Yeah. A very good morning, good afternoon, and good evening to all the people and the jury members present here. So we are Team Volatile from India, and we are working on sustainable and eco-friendly delivery system, which is of evaporative cooling system for fruits and vegetables. So this system, on this system, we are working with our mentor AgroWave, which are a startup, and they're working in the supply chain from farm to business. Now, we the Team Volatile, we are pursuing a Masters of Technology in Food Engineering and Technology from Institute of Chemical Technology, Mumbai. So this is Piyush Thakur, myself, Rajat Goyal, and Maruti Dubey. So we all three sat down across this entire time when the competition started, and what we had in mind was for the short food supply systems to develop a sustainable and a designer and an economical system where fruits and vegetable without any deterioration and with good and with low cost can be transported. Just to run about some facts that in India, only 2% of processing of fruits and vegetable is done up till 2020's data. 36% of fruits and vegetables are a wastage in India, which accounts for 60,000 crores of valuation. So we all got to know about this, and we had to do because most of the wastage happens not on the farm and not on the consumer side, but between the supply chain, where from farm to customers they are reaching. Either the valuation is being decreased or they are getting deteriorated. The present system was from market or from farm side, we are selling to the farmers are selling to mandis or the distributors or aggregators, and then the aggregators from their small like delivery partners like Swiggy, Zomato, Amazon, grocery, they are taking those small packets and then again dispatching them through their own supply chain of reefer vans and other ice packs, which are not sustainable. They're highly they consume energy very much, and only big players which have money can establish these kind of reefer vans for supply to customer. What happens at the end is that the customer gets a high cost product, and which is not as good as it could be. Now, our mentors agrowave business model is they are from farm to business. So they have developed this app and the price predicting model where they help, give the farmer the right price for their produce and help it deliver to distributors and wholesalers. Now, when we met them, our need with the agrowave matched very well. We wanted to develop something from distributors for the short supply chain, from local farmers to the direct customers. That was our sole motto. And what we kept in mind always is that the temperature control should be efficient, fruits and products should be delivered at lowest cost, and the freshness should not be compromised. Our motto was to develop a sustainable method, understand the needs of the customer, and to modify this space of short food supply chain and the local farming, local supply chains forever. And hence, we came up with this prototype. And now I like Maruti to continue. Yeah, Maruti, please go ahead.
Okay, so right now there are three ways of transportation of the fruits and vegetables into India. Considering India as a the market, the one is where they are transported in the open trucks and bags or with the ice packs. With this, there is a disadvantage associated with that is there is a loss of the freshness and along with the wilting of the green leafy vegetable. And second one is refrigerated van transportation. It's costly, and second thing is that it requires high energy input along with the consumption of the refrigerants, which could damage the environment. And the third one is that there are certain specific varieties of the fruits and vegetables for which a temperature of the refrigeration is not desirable. For example, banana is there, brinjal is there, and sweet potato is there. For those commodities, temperature between less more than 10 degrees Celsius up to 20 degrees Celsius is required. So for those varieties, this zero energy type of cooling chamber which you have developed will be the only option. So talking about the design of the prototype that we have developed, here you can see from the left side there is a fan, provision of the fan through which ambient air from the environment will be entering. The air will have an ambient temperature as the temperature of the outermost environmental air. It will be entering through this point 1, and as soon as it will come in contact with the 2. 2 is basically indirect evaporative cooling system unit, where there will be a provision of the tube and fan heat exchanger in which air will come in contact with the chilled water that will be running inside the tubes. And as a result of it, the drop down in the temperature of the air will take place by 4 to 5 degrees Celsius. And this air, which is less in the temperature as compared to the ambient air by 4 to 5 degrees Celsius, will now come in contact with the direct evaporative cooling unit, which is nothing but the number 3. Here, the water which will be from the water tank will be sprayed over the cellulose pad, or due to the spraying, the air will come in contact with this water, and as a result of it, temperature will be reduced along with increase in the relative humidity. So as the result, we'll be having an air which will be having temperature lower than 20 degrees Celsius and which will be having higher relative humidity as well. This duct is basically to collect the water which will be utilized for this direct and indirect evaporative cooling to get back it into water tank. So there is a kind of circulation of the water being taken place. This number 5 is basically pump, which will pump up water from this water tank into this direct and indirect evaporative cooling system. And here, this provision is basically to keep the fruits and vegetable. Here we can utilize trays as well, which will act as a baffles to circulate the air properly throughout the system. This is all about the design. And in last slide, I talked about direct and indirect evaporative cooling. If you ask me the share of which is higher in overall cooling effect, then I'll say about the direct evaporative cooling. Let's see how it is. In indirect evaporative cooling, as I said, water will be coming in contact with the tubes in which the air will be coming in contact with the tubes inside which the chilled water will be there. As a result, warm air will be decreased down in temperature by 4 to 5 degrees Celsius. But in direct evaporative cooling system, which you can see on the right side of your slide, there water will be sprayed over the cellulose pad, and the air, which is basically cooled air due to this indirect evaporative cooling, will directly come in contact with the water, and as a result, this stage will not only reduce down the temperature but also will increase the humidity. So these are the two basic criteria which are basically required for the fruits and vegetable to keep them fresh: lower temperature and higher relative humidity. And by using these two combined system, we are utilizing both of these. Okay, so this is how our prototypes looks like. On the left side image, you can see the provision of the fan. So air, the ambient air will enter from this side axially into the chamber, and there the provision of indirect evaporative cooling has been given through the tube and fin type of the heat exchanger. As it comes in contact with that, temperature will reduce down, and here in the central image you can see this provision of the cellulose pad over which the water will be sprayed. In the left side image you can see here the provision of one pump, and the water tank is at the base. So this pump will pump up the water from here and it will be sprayed over the cellulose pad, as well as it will be transported throughout this heat exchanger. So this will cause reduce in the temperature as well as increase in the relative humidity. And the provision for keeping provision of the space for keeping fruits and vegetables has also been given. So this is all. Now let's see the video of how it look like. So this is the fan through which air will enter, and at this side you can see the motor, which is submerged into the water, which is submerged into water present in the water tank, and there is a provision of the pipe which will pump, which will carry this water throughout the system of this cellulose pad as well as throughout the heat exchanger. So yeah, this is the provision for keeping fruits and vegetable, and at the bottom side, sorry, at the back side, there is arrangement for gate as well, which you can open, and it will make ease in the handling of this whole operation. And here, let me just show you. Here, trays can be arranged, which will act as a baffles, to the air, to make sure that the circulation of the air is taking place properly. And here, only the theoretical, information about this whole model has been given. Okay, so at the end, what we will achieve through this system, as it is two-stage evaporative cooling system, where in indirect evaporative cooling system, we are reducing down temperature, and direct evaporative cooling system, we are reducing the temperature as well as increasing the relative humidity. So as a result of this two, we'll be having increased coefficient of the performance, which will be 20% increment in the coefficient of performance. And due to this, we are expecting cost reduction to be more than 22%. And at the second point, we'll see less energy consumption. It is 60% less energy consumption. You haven't seen any type of electrical supply, major electrical supplier, or any other kind of the energy input being done into the system, which is advantage associated with it. And due to that also 25% reduction in the cost is taking place. It is easier to install, it is easier to operate. Anyone present there in the system, in the supply chain system, maybe any farmer or any short vendor, any other player also. So it basically doesn't require any hard engineering work. And with the common sense and common know-how of how evaporative cooling works, one can easily adopt to it. And the last point is lower carbon footprint. As we already discussed in the starting of this presentation only, that there is need to make green shift in the agriculture. And the refrigerants which are commonly used in the refrigeration system, which is right now available in the market, they are very hard to the ozone layer. Here, the reduction of environmental emission of the CO2 is being achieved. So at the end, I want to conclude this whole PPT in a gist, as that there are many peoples out there into short food supply chain who plays in kilos and not in the tons and in the quintals. So for them, it is hard to utilize this modern and sophisticated refrigeration system. And in many areas of the world, including India, the availability of the common refrigerants and refrigeration system is not there at the base level. So for them, this is the best solution. And also it can be, scaled up to four-wheelers, as well as it is customizable to vehicle size as well. And as we already discussed, there are various fruits and vegetables which particularly require temperature more than 10 degrees Celsius. For them, this is also a good option. And life cycle analysis of the carbon footprint also shows decline in the 50% emission of the emissions. So with this, we are open to discussion. Thank you.
Thanks very much to this team. Really excellent, really interesting. Love your pictures and graphics. And we'll have time for one or two questions. Please turn on your microphone and ask your question.
Good afternoon. I would like to make two questions. Do you listen to me? Sorry,
yes,
because
yes.
I have a pharyngitis and my voice is affected. Congratulations for your work. I would like to make two questions. Maybe I missed in your presentation. The prototype has a certain size. You plan to use this size or to scale up to put it larger? And I also ask if you test the prototype and why you are using the material you show that is in transparent. And another question is the energy supply to the fan. What type of energy you are considering? How can this be easily used?
Yeah, so I'll, okay, Maruti, you go ahead, you take this question.
Okay. Thank you for your questions. Answering to your first question, which you ask about how this can it be scaled up, or is it only is there any specific size? So as I talked in my presentation only, this is the size which we have made. It's basically for the two-wheelers, but definitely it can be scaled up. And basically scaling up can be beneficial in the cases where we have to utilize it for the particular fruits and vegetable. For those, the temperature of more than 10 or more than 15 degrees Celsius is required, but definitely it can be scaled up. And talking about transparency in the prototype, we just wanted to show how it looks from the inner side. So it will be clear to know where the exactly water tank is located and how direct and indirect evaporative cooling is also taking place.
So finally,
fan energy question also, Maruti. Where the energy for the fan and the pump will be taken.
Yeah. So actually we are aiming, and that's actually our future plan, to make it based on the solar system. So when vendor is carrying it over his vehicle, on the backside of the vehicle, with the minimum quantity of the solar radiation, that fan can be operated. That's the thing we are looking for in future.
Yeah, so just to add in it, when we tested it, the prototype on vehicles, we attached for the power supply with the battery. So with the motorcycles and the scooters on which we had tried and tested it, so through the energy of the vehicle itself, we have powered for now the fan. So these fans are very low powered, not very energy intensive fans, and the motor too. So the vehicle, two-wheeler vehicle battery could easily take up that load, and yes.
So let's get a question. I'm sorry, Christina.
No, just to conclude, for this type of transportation, what is the longest time or distance you are thinking? So, and also, please consider to analyze very well the type of material that you are going to use for instead of the transparent box, because you can get much better results if you choose the proper materials. Thank you.
Yeah, sure.
I see that we have Jordi Saldo with a question, hand raised. Go ahead, please.
Yes, thank you. My question is, I'm wondering if you have done any psychrometric calculation or a kind of an estimation of the reduction in temperature you can achieve, because when the air uptakes the water, the reduction, it depends on the humidity of the air at the other side. So it will depend on the weather, but also if the box, I imagine you pretend that this box could be somehow insulated, but if not venting outside, the moisture inside will increase, causing, as is said in the chat, risk of mold growing, but also reducing the efficiency of the system. So it's something I wonder if you have taken into account.
Piyush, are you on the call? Do you want to take up this question?
Yes. Sir, sir, basically the material used for the fabrication is just exemplary here. We are going to use the insulating material. Those are used in a refrigerated one system. So the insulating material will be same. And the second one is the humidity controller is also placed at the storage tank behind the cellulose pad. So the humidity can be controlled inside. This is only the prototype model. So we have not attached all the sensors and all the temperature controller and temperature measurement devices inside the chamber.
But Piyush, we had tested for temperatures, right? For like what can be achieved.
So basically, sir, in India, so in summer or winter temperature will be higher up to 45 and lower up to 10 to 5 degrees Celsius. So this prototype we have tested it in a summer and we get the result up to 18 degrees Celsius, because the first thing we used the fin and tube type heat exchanger, which reduced only 5 to 6 degrees Celsius, and after that in the cellulose pad, due to the increase in humidity, it reduces the wet bulb temperature of the ambient air. So that's why the temperature will reach to 18 to 16 degrees Celsius. And the only perishable fruits and vegetables, those are perishable, which cannot be refrigeratorily stored. Only those fruits and vegetables can be transported in this type of system. So this is the whole basic idea behind the fabrication of the system.
Yeah. And yeah, answering to your question related to mold growth in the fruits and vegetable during transit, I would like to tell you that this is the model which we are, which we are aiming to, especially for the short food supply chains. Basically, when farmer cultivate the vegetables and fruits at his farm, and when you take it to the market, basically during that transit, there is losses in the moisture as well as losses in the quality, which fetches him low prices. So our basic aim is to make that transit smoothly for the farmer, and not only for the farmers but for the vendors in subsequent stages of the supply chain as well.
Okay, super. Thank you for really that excellent discussion and responses to questions, and the questions also. So Team Volatile from India, and now we go to the third team, and our third team is coming from the United States. And here we have the Ag Economists, and I hand it over to you, Thomas and Savannah, please.
Thank you. Let me go ahead and share my screen.
Okay, we see it, but put it in presentation mode for us. Great, super. So the floor is yours.
All right, Savannah, do you want to go ahead and start?
Yes. Good morning from our side of the world. So we are the Ag Economists for local food access, and our project was about enhancing local food access in Kentucky through collective action in partnership with nonprofits. So my name is Savannah Columbia. I'm from Lexington, Kentucky, and I'm an Ag Extension Associate at the University of Kentucky.
And I'm Thomas Pierce. I'm from Elizabethtown, Kentucky, and I'm a graduate student in the Agricultural Economics Department at the University of Kentucky.
Yes, and we also have Alex Butler, who's from Lincoln County. He was not able to be here with us today. So our partnership is with Food Chain. Food Chain was founded a little over 10 years ago. They started out very small, but have grown to be a mid-tier nonprofit. Food Chain's original mission was to provide fresh food access in a food desert. A food desert is a term used to describe areas of the community that do not have access to affordable food. Food Chain is home to Kentucky's first aquaponics farm, and within the last few years has developed a teaching and processing kitchen inside their building. Food Chain's ultimate goals are to teach the community about food production, provide fresh food to the underserved community, and show the economic profit of the aquaponics model. So when the pandemic hit the United States in March of 2020, Food Chain shifted to provide fresh, locally sourced meals to our community members. And this was really big for them because they needed to find another way to serve their community, because the teaching and processing kitchen, which was used for public education and new job training skills, was not open for business at the time. So they pivoted to provide these fresh food boxes, which is seen on the right, and they created a line of local products for purchase at select retail stores. Food Chain gets their sources from 25 local farmers, 2 food banks, the God's Pantry Food Bank, and then a more local food bank called Glean Kentucky, and then 1 wholesale food supplier. They utilize produce seconds, which is the biggest part of their mission is to use food in the best way possible. So on the bottom right-hand side, we have some produce seconds that they use. And they also utilize some of their own produce from their aquaponics operation, and to put it all together as a hyper-local meal.
So now we'd like to take a step back for a moment and just talk about why produce is important, especially in the American diet. So you can see from this graph from the United States Department of Agriculture that since the 1970s, fruit and vegetable consumption has increased some, but it still falls well below that mark of what the American diet should be in terms of getting fruits and vegetables. So that really begs the question, why does that matter? And so this is a graph from the Produce for Better Health Foundation showing the estimated annual cost of that fruit and vegetable consumption gap in terms of diet-related diseases that could be prevented by getting fruits and vegetables in the diet. So you see here that it's estimated that in 2020, that produce gap caused almost $100 billion in health expenditures just from not getting enough fruits and vegetables. And then that's projected to increase by 2030 to $137 billion annually. So you can really see why Food Chain's mission of getting fresh fruits and vegetables to a food desert is so important.
Yes, so Food Chain's meal boxes are currently distributed to 133 households. Each box is about 30 pounds and includes 4 dinners, 4 lunches, and 4 breakfast meals. The boxes are dependent on whether the household can cook or not. To the right, we have an example of one of their boxes and kind of what comes in it. And their goal is to grow to 200 households per week. So for a second, I'm going to talk about what the value of these meal boxes are. We talk a lot about low income and food deserts in our presentation, so we want to put some numbers with that. Our low income households spend about 27% of their income on food, so about $78 per week. And if you look at our graph, on the left side, we have our lowest income group, and they have the lowest amount of spending on food purchasing, but the highest share of their income spent on food purchasing. Whereas our highest income households spend about 7%, which seems really small, but it's about $235 per week. So even though they spend a smaller amount of their income on food, it still brings back a lot more for their dollar value. So what this means is that each box that Food Chain can give to people is super helpful. Each box is about $45 in value for the dinner, lunch, and breakfast servings. and then each house costs $25 for delivery. But these meal boxes are provided free of charge. Both the food and the delivery cost are free to the consumer. And that $45 is over half of what the low-income community members spend on food weekly. So they're able to compensate half of their spending, which means they can put their dollars towards, other things that they might need, like school supplies for their children, or other clothing items. And especially now with the cold weather we're having, they can really put those dollars to use somewhere else because of what Food Chain is doing.
So the move to provide these meal boxes really highlighted the need for further development of Food Chain's food supply chain. So they discovered that there was ample produce available for distribution, but transporting and dividing the produce was nearly impossible for smaller nonprofits. So this was really for three main reasons. So transportation, there was no vehicle to transport excess produce. Storage, there wasn't space to store the produce. And then really a big issue was the amount of produce that nonprofits like Food Chain needed versus the amount that was actually offered or supplied. So essentially you had a situation where the food banks only could offer produce in pallet loads. And this is very difficult for a smaller nonprofit like Food Chain to distribute. So the bottom line is produce is available, but it's not easily accessed because of issues with one of these three that we've mentioned. So then that brings us to the solution, and we arrived at the solution through conversations with stakeholders like Food Chain, and we hypothesized that monthly or quarterly meetings with consistent scheduling could be helpful in maintaining our solution. And really, this solution really deals with collective action and a shared use approach. So we've broken down the solution into three action points, three components. The first aspect of this project is for stakeholders to buy into the shared use concept of the solution. So each food bank, nonprofit, and producer needs to understand how the status quo leads to wasted produce and decreases the reach of the food banks themselves. And buying in really secures that everyone is on board. So the second aspect of the solution is to form a committee of these food banks, nonprofits, and suppliers to coordinate the distribution of produce. So the committee would consist of all the interested stakeholders and would meet monthly or quarterly to really maintain the solution and coordinate distribution of produce. And the third aspect is rotation of responsibility, as determined by the committee, for stakeholders to each take a portion of the task of dividing and distributing the produce among the food banks. So this would ensure an equal allotment of liability and investment among the members. And what makes this possible is the shared purchase and use of a vehicle for actually distributing the produce. So this is actually the tangible action item that allows Food Chain and their produce donation partners to shorten the food supply chain.
So our impact is that Food Chain could reach their distribution goal and other nonprofits could increase the reach of their work. And this would improve and develop the short food supply chain happening between Food Chain suppliers and their final meal box consumers. And in conclusion, like Thomas talked about, the produce gap leads to declining health outcomes, and food banks struggle with efficiency in providing their produce, and our solution enables greater reach and decreased food waste, and our solution can be applied to food banks to strengthen their short food supply chain on a global scale, and applied to Food Chain to strengthen their short food supply chain on a local level. And that is all we have today.
Great. Thanks very much, Thomas and Savannah, for another perspective from another corner of the world. Are there any questions from the audience? Please just open your microphone or type your question. No, doesn't seem like it.
I'll ask a question since there aren't any others. I'm wondering about working with other food banks in the area, because on the one hand, I appreciate that your goal was so tangible to reach 200 households a week. But on the other hand, I wonder if you could expand that goal by working with other nonprofits, maybe in a regional area. Do you have information about other food banks that are around you and how you might collaborate?
Yeah, I think that is really a possible goal to expand past 200. When we talked to Leandra, who was our industry partner at Food Chain, their goal at the moment was just to move up to 200 households per week. But I think once they get there and can really have a handle on that amount, they can move into larger numbers of meals provided. God's Pantry has a few food banks in the central Kentucky area, and then Glean Kentucky is a food bank that takes seconds straight from the farm. So they cover a large area of Kentucky as a whole too. So they could all coming together with our collective action can really improve way past 200.
And when we spoke with Food Chain, they really kind of expressed to us that this is something that can apply in other regions as well, because it's a common issue. I know, for example, where I'm from, about an hour and a half from where I am at university here in Lexington, Kentucky, it's a similar issue where you have smaller entities, maybe even a soup kitchen, for instance, that needs some of this fresh produce, but it's almost locked up by a larger distributor that can't distribute in small loads, as we've mentioned, to a specific smaller agency. So our solution would really be applicable to those types of applications as well.
It's really interesting to hear what is maybe the opposite of the problem we imagine, that we're missing an intermediary. Instead of having so many intermediaries, we're actually missing the key. Well, and your aim is to provide that. Anything else from the audience?
No. All right, then we have one last team, and that's Team Elegant. I'm very sorry if there was some misunderstanding, but we have one more team. It's Food Elegant from India, from the University of Kerala. You will be giving a presentation on smart milk ATM system. So I please invite you to share your screen. Are you here?
Ma'am, is the slides visible?
Yes, only if you can put it in presentation mode, please. Then we can better see your screen.
Okay.
Yes, perfect. Go ahead.
Good afternoon, all. Respected dignitaries, I am Binjupi Babu, pursuing Master's degree in Food Science and Technology, Kerala University of Fisheries and Ocean Science, Kerala. And I represent the team, the Food Elegant. And I would like to introduce my team members, Amrita S., Yedukrishna R., Abraham Binu, and Binisha NL. Let me start my presentation. And the title of our project is the Smart Milk ATM System. So India is the leading producer and consumer of milk across the globe. And the Indian dairy sector is divided into the organized and mostly unorganized, which is approximately 75%, And with the increasing population, higher disposable income, higher per capita consumption, larger vegetarian population, demand for hygiene, etc., the demand for milk bound to increase, and on the milk procurement and distribution side, there has been major challenges arising due to the higher perishable nature of the milk. This sector is also plagued by a lack of infrastructure for collection, transportation, and the processing of milk. Most of the cold storage facilities are either located a few hours away from the dairy farm or lack the proper electricity grids required to support the cold storage. The quality of milk deteriorates till the time it reaches the ultimate consumer. As milk is a highly nutritious food product, it is more prone to the microbial growth. As the length of the supply chain increases, the quality of milk decreases. So in order to shorten the length of the supply chain, we try to develop a smart milk ATM system wherein the milk is processed within the ATM and it's delivered. So in the Indian dairy sector is the leading producer of milk globally, and there are over 300 million bovine animals. The total production is over 198 million tons, and there is a robust growth of 5 to 6% in 2021-22, and the sectoral revenue generation is 1.5 trillion according to the 2021-22 project. And the global milk production. From this graph, we can see that India leads the world in milk production, 196 million tons, and the total world milk production is 852 million tons. So let me give an overview of our project. The intended product is the whole milk, which is fresh and it is minimally processed. And the focus area is the villages, rural, semi-urban areas. And the target consumers, it is the lower economic strata. And the technical feasibility is, it is feasible with the existing technologies, and the environmental impact, it is minimum. Next is the objective of the Smart Milk ATM project. The main objectives of our project is to shorten the supply chain of milk, to provide safe and wholesome milk to all the people, and to empower the rural women workforce, and to ensure the sustainability via the supply chain, and to reduce the environmental pollution. The general practices in industries are: first, the milk is collected from the farm, then it is stored and transported to the plant where the laboratory testing are carried out. Then the milk is processed within the plant and it's packaged and then marketed. And here we are trying to reduce the supply chain. The milk is directly collected from the farm and it is transported in a truck, and the processing, minimal processing is done in the milk ATM. Then the requirements of the our project are the control center to control and monitor all the operations of the short milk supply chain, and the approved milk farms, the farms which are approved by the industry to collect the milk, and a mobile testing laboratory to conduct the platform test of the milk, and the milk tankers for transportation of milk from farm to the vending machine, and the milk ATM. These are the smart vending machine that dispense the pre-processed milk to the consumers. The rest of the presentation will be taken by Amrita. Thank you.
Thank you, Denju. Let me now move on to the next portion, that is the milk ATM. Here, the milk ATM supply chain. The milk is tested. Milk is first collected from the farms approved by the industry. Then it is tested for the quality and safety by the mobile testing laboratories. The general tests include determination of solid non-fat content, that is SNF, and fat, and it also includes some organoleptic test. And when the milk is up to the standards, milk is then transported to a milk tanker by a pump, and it is also provided with a cooling facility. Since we all know that milk is a very perishable product, the chance of microbial contamination is very high. So a proper cooling facility should be provided during the transportation also. That is, the temperature of the milk is maintained below 5 degrees Celsius. And then milk is directly loaded into a vending machine, that is a milk ATM. And it also have a proper chilling unit and a mini heating unit to ensure the microbial reduction. And then the consumers, upon inserting the cash, can obtain the minimally processed milk, and it is can be collected in containers. As we all know, the usage of plastic-like materials can be minimized by this, as it's very eco-friendly. And then the whole process is then controlled by a control center of the industry. This is a figure that shows the picture of an Indian milk farm, and the cows are arranged in tail-to-tail system so that the spreading of communicable diseases can be prevented. So then next, that is the major beneficiaries of our project. It includes small and medium farm owners, women rearing cows, skilled and unskilled farm workers, educated youth, like truck owners or drivers, then consumers. So these are the major benefits. They are the major beneficiaries of our project. That by our project, we provide a regular income to all these people. And next, the figure shows the participation of a rural woman in rearing the cows. The rural women, of course, they play a very important role in rearing the cows. They get the fodder and feed for the cows by traveling a very long distance, and they try to contribute the most of their time in rearing the cows, even though in the home, even though it may be very small in number, like 1 or 2. So our project, through our project, these rural women also get benefited. Then the major advantages and disadvantages. The major advantages include fast and minimal processing. It's a very eco-friendly, since plastic packaging is eliminated. Low energy consumption than industrial processing. Like in the case of a dairy plant, the chance for the use of electricity is very high. So here we are using a solar system. They were reducing the energy consumption, and the job creation for rural population, especially the women, and it also boosts the rural economy. And in the case of disadvantages, only whole milk can be processed, other dairy products cannot be obtained by this. And similarly, older population, they may find it difficult to operate the milk ATMs. So as a summary, as she had already mentioned, that India is a leading producer as well as consumer of the milk across the globe. The Indian dairy sector can be divided into organized and unorganized. It's mostly unorganized, like 75%. And since the milk being a perishable commodity, it requires immediate processing. According to the National Dairy Development Board, a study they conducted, the expected consumer demand for good quality fresh milk is 266.5 million metric tons in 2030. So, as she had already mentioned, in the case of the Indian dairy sector, most of the portion is unorganized. So the farmers may not get the proper infrastructure, they may not have a proper cold chain. They cannot properly maintain a cold chain system or chilling system, or in the case there may be chance like the cold storage system may be located far away from their farms. So there are a lot of chance for the contamination of milk when it finally reaches the consumer. So all these problems can be addressed by a short food supply chain in dairy sector. And in the case of the smart milk ATM system, it has the potential to serve the increasing consumer demand. It provides safe and wholesome milk to consumer at a very low cost, and also it's having a good quality. And this whole process is sustainable as it involves eco-friendly supply chain. There's a usage of plastic, and it also helps to generate a proper regular income for the rural population. Especially, it mainly focused on women empowerment, especially for women from rearing cows and supplying milk to the industry. So our initiative can boost the nation economy by developing the dairy sector. It provides a proper livelihood to the farmers and reduces the rural poverty, and it empowers the rural women, and it provides a regular source of income to the rural household. And finally, but most importantly, it properly ensures the food safety. Thank you.
Thank you very much, Team Food Legend. Thank you very much for your interesting presentation. Are there any questions from the audience? We have a couple of minutes for questions.
May I?
Please.
Yes, I have a question.
So,
please,
congratulations for your project and your idea. I see many advantages, but many challenges, because I'm imagining, so if I understood well, please confirm that someone will control the quality of the milk before this milk is transported to the ATM equipment, right?
Yes, ma'am, I'm taking up that question. We are actually processing the milk in between. There is no processing actually. There is only minimal processing, like chilling and preheating actually. But from the farm, while we are connecting, we are doing the platform test using a mobile laboratory, so that any risk during collection of milk can be eliminated at that stage.
So you collect the milk and this equipment. Do you have an idea of temperatures and times of the treatments? That is, how is it going to? What is the amount of milk that this equipment is going to store? And for example, how is going to be controlled the time till consumption? And who is going to do it? The control and monitoring of these machines next to the populations.
Since this is a smart milk ATM, everything is controlled and monitored by a control center, which is set up by an industry, where the information regarding the temperature, time, and quantity of milk will be sent to the control center automatically by this ATM machine to the control center, and the officers or people sitting in the control center can monitor 24/7 the working of this ATM, the quantity of milk in the ATM, the time to refill the milk, the temperature, and if there is any fluctuation in temperature, we can easily prevent that milk from being dispensed from the control center itself.
Let me ask you one question. The consumers, when they buy this milk, do they boil it before consumption, or is it ready to drink?
Actually, in India, there is a practice of boiling the milk before consumption. But here it is not necessary actually, because we are preheating the milk to avoid any contaminated, any pathogenic organisms.
Thank you.
Thank you.
Thank you very much. I see, Lilia, you have a question?
Yes,
That's a very bad sound. Okay, so you put your question. The question is, how are you going to convince people to buy from you? I mean, reasons like helping women are also used for other companies, and this other companies have big recognition.
Okay, I take up that question. Actually, that's a good question. We also had thought about this, but actually, in the beginning of the presentation, we had told that this is a project based on existing technologies. We have put them up together so that it becomes a short food supply chain, and we can deliver the safe milk to consumers. So smart milk ATM is already, and it's not smart, but milk dispensing vending machines are actually there in India. It is not a new thing. the milk dispensing machines are already in India. It is set up by industries actually, milk processing industries. After them processing the milk is already filling the milk in ATMs, and but it is not widely used. It is not widely used, but people are still purchasing or taking milk from this vending machines. So we don't think that there is a problem of convincing people about purchasing milk from or taking milk from a vending machine, because it is already practiced. What we have done is we have avoided the processing in industry actually, and we have brought a miniature processing unit inside this milk ATM. So whatever happens in the industry, that same thing can be done in a mini scale inside this milk ATM. So people can easily get milk. And we are planning to set this up in rural areas so that people can access milk 24/7 and can get safe milk with the same quality as that processed in industries.
Okay, great. Thanks very much. Thank you to Food Team Elegant and to all teams for your presentations, and also to the audience for your interaction. We really appreciate that. So now we take a 10 to 15 minutes break. I want to apologize for our delay and also for the misunderstanding with the technicalities. But please stay because now the advisory board are giving their points to the presentation and to the interaction. And in 10 to 15 minutes, we meet back here. So please come back. And in the meantime, we will share a video about our competition. Great. So now we're back, and we really apologize for this delay, but we had some issues counting the points, but we wanted to really make sure that we have all points from, we're a group of people from the advisory board, and we are in an online setting, and depending on technicalities, and now we're sure that we have the right winner, also because the winning, the points are a composition of many different factors of the reports, of the presentation slides, of the way in which the teams give their presentation, the way in which they answer the questions, and all these combinations have, there are many different factors, and now we're sure that we have the right team as a winner. So before we announce the winner, we just want to thank especially our teams for joining us for these 4.5 months. We're really impressed with your reports and your presentation, and most of all your solutions to this topic. And we also thank you very much for engaging and for participating in the online trainings. It was a pleasure for us to work with you, and you were all very active and very, you wanted to learn, and we also got that feeling out of you. And I'm sure also that people here today have seen that you found some really great solutions that are innovative and that are important also. And we really encourage you to continue working with this. And we're also looking forward, we would like to stay in contact with you and looking forward to see what comes out of these. So thank you very much for all this. I think I can speak for all of us when I say this. So now we come to the announcement of the winning team of this year's Food Factory for Us. And it is Economists from the United States. So big congratulations to you. You did a great job. Yes, congratulations. Big applause. Yeah. Thank you very much. I think that's all.
Let's get a picture of them. The team.
Yeah. Please, can you show yourself? I think Savannah had to leave, unfortunately, but Thomas, maybe you're still here.
If you stop sharing for a second, Lena, then everybody would be on the screen. And for the remaining people and students that are still here, if you could just for a second open your cameras. As I say, I realize I don't have my camera open, and that we can take a picture. And so I see the pictures coming online. That's perfect.
Yeah, it would be nice with a group picture.
Maybe also for the remaining that they open up. Oh, we do it. Have one more. Perfect. Then everybody smile, and I will take a screenshot. Perfect.
Thanks very much. All right. So before we leave, just wanted to remind our students, please again fill in the learner evaluation. You find it on our website, because we're doing action research on this whole process, learning process. And if you're interested, for everyone else in following our competition, you can find, I can send you here the link in the chat to our website. We also have a newsletter from ISEKI that everyone who's interested can sign up for. We have many interesting news about our projects, about works we're doing in the association. Yeah, and then I think we can say goodbye, and thank you very much for everyone's participation and for joining us today.
And we can let you know that this competition will continue. There will be another one next year and in the years to come, sponsored by the Fairchain Project. So please let your colleagues know, and we welcome back teams who'd like to re-participate. So stay tuned.
Bye.
Thank you, everybody.
Thank you.
Bye.
Thank you so much.
Thanks, Thomas. Bye.